with the homework. All right, so here is the next video in the daily works. So I did kind of go overboard with the homework this 9 weeks, but there was a purpose behind all that because this is something that you really need to know and that can break you if you don't understand it for the next couple of years. So let's get into it. This particular assignment is one of the math football assignments. And this is one I didn't went over at least twice, both in a Wednesday tutorial and like 2 times in a lunch tutorial. So these were the page numbers that this page dealt with, and it wasn't a packet that you were given after the freeze. So this was a homework assignment that happened after that hard freeze on Tuesday after the Martin Luther King holiday. Now, I will kind of help you as best as possible, but like I said, I'm not going to read because you need to read. So first thing I need you to do, read the directions so you can see what you need to be doing. Now, this particular lesson was dealing with the three types of numbers, but in class we went over 4 types of numbers in the system of numbers that y'all will be dealing with in middle school. There is one more category that y'all will learn in 8th grade, but once again, that is 8th grade and this is 6th grade, so you ain't got to worry about it for now. Now, one of those categories was natural numbers. I told you natural numbers were counting numbers. So that's when you just put up your fingers. Usually you start with a closed fist and you start counting. Natural numbers. Okay? And you just keep counting until infinity. If you can count it, it's a natural number. If you can use your fingers and toes to count it, it is a natural number. Now, let's go to the next category. And I'm going to also show you a diagram of how all this stuff is related. Next is whole numbers. You should remember whole numbers. You mostly have been dealing with whole numbers a lot in your when you were in elementary school. Whole numbers are counting numbers, including 0. So all this meant was instead of starting at 1, you started at 0, and then you just kept counting. That was it. Like you started at 0 and you just kept counting. That's it. Like you should see the connection between these two already. I will be showing some examples of what they look like too, so give me a moment. Next on the agenda, if it's not natural, if it's not a whole, then the third level means you're dealing with an integer, or integers in this case. Now, integers into simple form. There are 2 types of definitions I like using for this one. They're counting numbers and their opposites, which is one I like to use. Or another definition you can use for integer are positive and negative whole numbers, which is exactly what they are. So for integers, these are the 2 definitions I like to use because they pretty much sum up what it is. It's counting numbers and their opposites, or positive and negative whole numbers. It is what it is. Oh, let me put for this one, includes 0. Includes 0. So counting number and their opposites and including 0. And the reason I put including 0 is because 0 is neutral and it doesn't have an opposite. So if I just put counting numbers and their opposites, it kind of eliminates 0 because 0 doesn't have an opposite. But it's also including 0. That's also why I like this one too, positive and negative whole numbers, because that reminds you that integers can include 0 also. Now, if it is not a natural number, you cannot count the number. And it's not a whole number. It doesn't have 0. It's not 0 and you still can't count it. But it's also not a positive or negative counting number, which means it can't be an integer, there is one last category you need to know and understand, and that is rational numbers, which is the majority of the numbers we use. And for this one, can be written as a fraction. Now, usually when you see this one, it says can be written in A over B form. A over B is a fraction. It's a fraction. So can be written as a fraction. So when you're looking at a number, if you can write that number or rewrite it or convert it to a fraction, change it into a fraction in a correct manner, then it is a rational number. Rational number has two versions. You have the ones that terminate, which means they do have a stopping point. And then you have the ones that repeat. They're repeating. So they either terminate or they continue repeating, but one of the two things is going to happen. Now, there is a third one, but like I said, that third one is for your 8th grade teacher to tell you. That has nothing to do with me. Now, I am going to draw a diagram of how all this is related and give you some examples to work with. That way you are able to answer these questions as best as possible. Some students that have answered this assignment keep copying and pasting, and I have been taking off credit because that is basically plagiarism. You are not allowed just to copy offline. Now, yes, I did say you can use Google to help you, but when it helps you, you still have to put it in your own words. So let's get into this diagram. So in our inner circle, this is probably going to be a little lopsided because I ain't got a lot of space I'm working with. We have natural numbers. Usually you will not see natural numbers for the simple fact whole numbers pretty much have all of them, including 0. So this kind of dissolves into whole numbers over time. But I'm going to just put it here for the sake of the example. But if it is a natural number, but you're not given that circle, just include everything in whole numbers. Next level is whole. After whole numbers is integers. And after integers, I am not going to redo this into perfect circles, so please don't ask. All right. So how this works is you start with the very most inner one. If the number can be labeled that, you start with its very most inner circle, and then you work your way outward. Now, how this works, let's say, for example, they wanted me to classify the number 2. Well, 2 can go in quite a bit of different places. Since I can count 2 on my fingers, that means it is a natural number because I can count it. It's also a whole number because whole numbers are counting numbers. It's also an integer because integers include counting numbers. And rational numbers can too be written as a fraction. Well, actually, yes, it can. I can do 2 over 1 to make it into a fraction, which also makes it a rational number. So you would think I would write it in every place possible because it is all of them. But that is not the case. You would only put it in the one that is its very first category. So that means 2, since it is a counting number, will go here. But if you look at how the circles work, it is also already included in everything else. Because remember, I told you, you work from the innermost circle and work your way out. So if it goes here, it's already in every other circle because this one is in all of those. Now, another way to look at this is if you have 3 and 0/10. This is still a counting number. Why? Because this is 0, I can simply take this away and it will still leave me with 3. So this is another number that would go in natural numbers. If you have something like this, well, you're going to say, hey, that's a fraction. So that should go in rational numbers. And I would tell you, you're half right and you're half wrong. Because while this is a fraction, solve the fraction and see if you can get a counting number. Well, 6 divided by 2 equals 3. Well, since this fraction is equal to 3 when solved, it would actually go in natural numbers, even though it looks like a fraction. But it's not so much what it looks like, it is its value. The value of these numbers is what you're classifying. So if the value is a counting number, then you put it where counting numbers go. For whole numbers, the only difference between these two, as we said before, is a 0. So if you can count it, it goes here. If this circle is not here, then it all goes in whole numbers anyway, including 0. Now, the only difference between these two already have every counting number you can think of. So this mostly will be for its opposites. So that's the negative numbers. So -2, -3.0, -8/4. I'm not going to do 8/4. Sorry. -12/3. And you might be thinking, Ms. Hamilton, why did you put -12/3? That's a fraction. What did I tell you about fractions? If you can solve it and the value of it equals a counting number, then it goes in whole numbers, natural numbers, or integers. This one is an integer because it's a negative number. When you divide 12 by 3, you get 4. So this is basically -4 written in a different way. So I am allowed to put it in integers because -4 itself is a counting number and -4 is its opposite. Last but not least are rational numbers, which is anything that cannot fit into the other 3 circles. So that is things like 1/2, 3/3, 5/4. You might be thinking, hey, why didn't this one fit up in here? Well, if you simplify or even divide 5/4, that equals 1/4. We don't count in fourths, so that's not going to work with counting numbers. You also have numbers like -3.2. Halves can also be negatives because the fractions can have negative values. That includes percent. So 82% can also go here as a rational number because 82%, when you change it into anything, will be a fraction that cannot be simplified to a counting number. Sometimes some percents can go in these other categories. And then what am I missing? Fractions, decimals, percents. I think that's it. Yeah, I believe that's it. Or all I can think of at this moment. So I hope this breakdown helps you answer these questions correctly because you do need to have a knowledge of this information to do this assignment. So good luck and I'll see you later.